Hello, welcome back. Today let's try to solve another Leetcode problem. 1964. Find the longest valid obstacle course at each position. Let me explain the problem a little bit. So we have a obstacles. So this numbers inside means the height. So basically we're gonna find the longest increasing subsequence. So for example, 1, 2, 3 at this position. So for the 3 at this position must be included. So at this position it is 3. At 2, this 1, 2 position, the longest is 2. For 1, it is 1. But for the last number, this 2 must be included at 1, 2, 2, so it is still 3. So it means it's not strictly increasing. It is just non-decreasing order. Yeah, we just need to find the longest non-decreasing order, include the current index. Let me go to the whiteboard to explain a little bit about the solution I'm going to use, and then I go to the code editor to finish the coding. So you should check this n. N is 10 to the power of 5. It means if you just use O(n) square, like the longest subsequence, longest increasing subsequence, you're gonna check two loops, I and z. You're gonna time limit exceeded. You have to use another way. So this way is patient sort. So it is a greedy idea. So the time complexity is just O(n) log n. Yeah, and for us, actually, for each of the index, we don't need to check one by one. Otherwise, it will be n square of log n time. I mean, you need to, for example, for this position, you have to check one by one until here, and then for this insert, it is a log n. But for this time, at this position, it is n. Yeah, n times log n, and you need to check each positions. There are n positions, so it is n squared times log n. Of course, it will not work. So we have to use some better way. Yeah, while we are using the patient sort, while we are sorted, we're gonna finish our result, and then it is just O(n) log n time. Let me go to the whiteboard to explain a little bit about my method, and then go to the code editor to finish the coding. I will use the previous example, Russian double ever loops. So I will use this sequence 3, 8, 6, 5, 7, 4 as my patient sort sequence. Yeah. So for this sequence, basically, for the patient sort, I'm going to put it inside of piles. For example, for the first number, I'm going to put a 3 here. For the second number, if it is more than this 3, I'm going to put it here. For the next number, 6. So if it is less than, more than 3 and less than this 8, I'm going to put just below it. And for the next one, 5, I'm going to put 5 below this 6. Up to now, our array is 3, 5, and 7. It is always in increasing order. Yeah, last one, I'm gonna put 4. 4 is bigger than 3, 4 is smaller than 4. Then 5, I'm going to put the 4 here. So up to now, our sequence is 3, 4, and 7. So the longest is 3. So this is the O(n) log n time. Because when we want to insert a number, for example, this 4, we can always use the binary search. Here, use the binary search left. Yeah, to insert it inside. Basically, that is a log n time for binary search. Now, I will use the similar idea from the Russian double ever loops to our problem. Yeah, our problem is very long title. Let me find the title. Yeah, find the longest valid obstacle course at each place. Basically, it's the same. Yeah. Now let me write the template first. After that, I'm going to change a little bit of the template to finish this question. So basically, for this patient sort, the template is like this. This is the longest increasing sequence. This means a pile array. We're gonna put the numbers inside the piles. And then, so for here, I'm going to write the template code directly. So for x in obstacles, I'm going to check the index. So the index should be bisect left. Yeah, it's quite slow. Let's wait for a second. Yeah, bisect left, and I'm not sure if I can finish the recording of this one because it is just not responding. I have to wait, yeah, for a second. Yeah, it's okay, I think. Let me finish the coding. So we're gonna put it inside for the, first of all, will be the obstacles array. And then I'm going to binary search this left. Yes, here is just the template code. I just need to check if this I equal to length of the LIS. Then I'm going to append it inside. I'm going to append the, yeah, let's say I'm going to append the numbers, because basically this is the template. This number is x, because for x inside the obstacles. Now, if it is not equal to the length, so I'm going to insert it inside. So lis.I should equal to x. Yeah, so basically this is for solving the longest increasing subsequence problem. And finally, I'm going to return a length of LIS. So basically, this is for solving the longest increasing subsequence, and this is for strictly increasing subsequence. It is not for our situation. Our situation, the 2 is more than 2. We're still going to count it. Yeah, 1 to 2, we're going to still count it as 3. And our result is just an array, not the length. So from here, I'm going to prepare a result array, because this is the result. I'm not going to return the length, just the result. Yeah. Now let's see what else I need to change. Basically, I need to append something inside my result array. So like here, if I equal to the length, so the LIS array should append this x. At the same time, I think my result need also to append it. So what I need to append, it is I plus 1. Why? Because I equal to 0. Actually, when I equal to 0, yeah, it means my insert position is at index 0. Actually, my length is I plus 1. It is 1. When I insert at 2, the I equal to 1. Actually, it is 2. So it should be I plus 1. Yeah. So this is the first change. So also for this one here, longest increasing subsequence I equal to x. Here, I should also append the value. So I can put it outside, because in if else situations, I should always append the I. So I will put it outside the if else check. Anyway, I will append the I plus 1. Now let me run it just to check what happens. So the result, it's not a result, it's just an empty array. So I did it on purpose. I mean, it's not here on purpose. I did it list assignment index out of range. So let me check if I did something wrong. So for x inside, this is I equal to bisect left. If I equal to length, this should append. Yeah, because here, let me finish, actually finish all the coding first, and then I will explain what happens. Let me run it again. This list I equal to x. Let me check. Oh, there's something wrong. The list assignment index out of a range. Yeah, let me print it out the I to check what happens. So I equal to 1. List List 1 equal to x. Yeah, this is something wrong. I used the wrong template. The template is the longest increasing subsequence. It's not the obstacles. Yeah, so for sometimes, even you are familiar with the template, you should know why you should use it. Yeah, because I just type it too fast. I didn't check it carefully. Now let me explain why we're gonna use the bisect right. So if I use a bisect left, I will not get the right result because bisect left is for checking in strictly increasing. Yeah, for the patient sort algorithm. So if I use that, you can see that it is 2. It is not 3 because when I use bisect left, so here I have like this number 1, 2, and 3. When I put 2 inside, so for the bisect left, it is at this position. So the index is 1, and 1 plus 1, it is 2. So finally, I'm going to return 2. But actually, I should return 3. So this is why I should use bisect left. When I use bisect left, even they are equal. Yeah, 2 equal to 2, but I still put it behind this 2. It means my index is 2. 2 plus 1 is 3. This is why there's also a little bit of change for the left. Yeah. Now let's just run it to check if it really works. Yes, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it's pretty fast and it's passed all the testing cases. Now let's just check the time complexity again. So as you can see, this is just a for loop, and for the obstacles, the length is just n. So for n inside, here is a binary search. For this binary search, it is just log n maximum. So the time complexity is n times log n. That is why we can pass it, and it's so fast. Yeah, it's a pretty good question in Leetcode because this is directly using the patient sort or log n time greedy method to solve it, and also it is a DP method. It is a DP idea, but the real method is greedy. And finally, we use the binary search. It is called patient sort, and this is basically a template question. It is even similar to that Rossendale ever loops problem. Because for the Rossendale ever loops, actually you need to use a greedy idea to sort the array first. But this is simpler than that if you know this kind of a patient sort algorithm. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode problems like this. See you next time.